Do you know why the rainbow circle can realize powerless walking? The rainbow circle will be pulled open and placed on the stairs. At this time the interesting phenomenon occurred. It is actually a layer by layer step down the stairs. What is going on? Let's look at an interesting experiment. This is a completely stretched out rainbow circle. At this time it will be released. An interesting phenomenon appeared. The rainbow circle did not fall straight down. On the contrary, its bottom is completely stationary. During this process, the rainbow circle above it shrinks layer by layer. Only when it is completely contracted does the rainbow circle begin its freefall motion. This phenomenon is obviously a little different from what is imagined, so why does the bottom of the rainbow circle remain stationary during the fall? First of all, it is not reasonable to call the bottom of the rainbow circle static or suspended. Through observation, we will also find that when the rainbow circle is in the fully extended state, the gap between each rainbow circle from top to bottom is gradually becoming smaller, and the upward pulling force received from top to bottom is also becoming smaller. Therefore, the acceleration of the rainbow circle in the falling is not the same, and the bottom of the rainbow circle has not felt the disturbance from above. The falling speed is too slow will appear to be stationary illusion. Look at the phenomenon of the rainbow circle walking up the stairs. When the height difference between the two ends of the spring, the higher side of the roll of the point will be beyond the lower side. So when people let go, the binding force of the higher ground will disappear instantly, and when it exceeds the central axis, it realizes the effect of going down the stairs, and this process repeats the cycle, which looks very magical. Although the rainbow circle appears to have no power source throughout the game, it is constantly converting gravitational potential energy into kinetic energy for descending the stairs, which doesn't make much of a difference as long as the staircase design is consistent. Rainbow rings were first made of metal, and as they grew in popularity, they eventually evolved into plastic rainbow rings in a variety of colors that have captivated both children and the elderly alike. In fact, in the beginning, the appearance of the rainbow ring is purely accidental. Its prototype is very flexible spring, used for ship vibration damping. Engineers accidentally discovered its wonders, and only after improvement did it become the rainbow loop that has become popular all over the world. You must be wondering what this is all about. What is the purpose of trucking in so many little black balls and dumping them all into a pool? This is a reservoir in Los Angeles, the United States. According to statistics, will be a total of hundreds of millions of small black ball put into a number of reservoirs, and finally the entire water surface will be covered by all the black ball, completely unable to see the water surface. Black balls one by one next to each other, densely packed into a black. In fact, these small black balls is the sun ball. It is made of polyethylene plastic, diameter 100 millimeters, equivalent to the size of an adult's palm. Its interior is hollow, so it will naturally float on the water surface after being put into the water, and its role is to save water. The original purpose of the shade balls was to prevent deterioration of water quality in reservoirs by blocking sunlight, resisting UV radiation, reducing bromide, and preventing algae growth. Bromide is a compound that is particularly susceptible to sunlight exposure because bromide ions react with ultraviolet rays from sunlight and then produce bromide, so these shaded balls act as an ultraviolet barrier to prevent water from being contaminated by bromide. Later, it was found that the water-saving effect of such small balls is also good. By putting a layer of small balls on the water surface, the direct sunlight can be isolated, thus reducing the evaporation of water and achieving the purpose of water saving. It has been measured that the use of shade balls can effectively prevent pollutants from entering the water and reduce water evaporation by 80% during droughts, which is very effective for those places where water is scarce in drought. Shade ball composition is high-density polyethylene, adding carbon black and anti-ultraviolet additives, which is characterized by very resistant to ultraviolet radiation, even after a long period of exposure to the sun is still a stable composition, non-toxic, tasteless, and will not produce volatiles, will not cause secondary pollution of water sources. After spreading the ball over the water surface, it can also well block dust and airborne pollutants from landing on the water surface. It is estimated that after these reservoirs put shade ball, the annual evaporation will be reduced by about 1 billion liters. But to put so many shade ball, the cost is not low, the total amount of more than $35 million, but compared with other water conservation methods is much cheaper. Have you ever wondered the question, faced with the mass of the Earth, which is as high as 60 trillion billion tons, how exactly was it calculated in the early days without any precision instruments? As early as more than 2,000 years ago, when Aristotle, an ancient Greek philosopher, was observing the moon, he noticed that a round shadow appeared on the moon, so he guessed that the Earth might be a sphere just like the sun or the moon. However, since gravity had not been discovered at that time, people did not agree with Aristotle's viewpoint and suggested that if the Earth was a sphere, then why did no one fall from this sphere? It wasn't until the early 16th century, when Portuguese explorer Magellan and his fleet completed mankind's first circumnavigation of the globe, that the Earth was finally proven to be a sphere. Then when Isaac Newton proposed gravity, another problem was discovered. Since all objects fall downward due to the Earth's gravity, how much does the Earth we live on weigh? At the end of the 18th century, the British physicist Cavendish derived the golden substitution formula capable of calculating the mass of the Earth based on Newton's equation of gravity. The acceleration of gravity, g, and the radius of the Earth, r, are not difficult to derive, and the weight of the Earth can be obtained by measuring the gravitational constant, g. In response, Cavendish came up with a brilliant solution. He installed a small ball at each end of a thin rod suspended from a quartz wire, and when the balls reached complete rest, he placed a lead ball of greater mass on the same side of each ball. According to the explanation of Newtonian mechanics, gravitational force exists between any objects, and these two small balls will be slightly twisted by the gravitational force of the two lead balls. Then, by measuring the angle and time of the twisting of the spheres, the universal gravitational constant g was successfully derived, which is equal to 6.67259 times 10 to the -11 th power. And through extensive experiments, it was calculated that the density of the Earth is approximately 5.481 times the density of water. Eventually, through these measurements, Cavendish succeeded in calculating that the weight of the Earth was 5.977 times 10 to the 24th power of kilograms, or 60 trillion billion tons. Compared to today's measurements, Cavendish measured the Earth's mass with an error of only 0.65%, which is quite impressive. Who says Chinese knives are inferior to Japanese knives? This kind of knife from the border town of Yunnan not only can easily cut through 8mm steel bars, and even with a wave of the hand can cut through 50 towels, it is the anti-war sword team used by the Tusa knife. Its power to cut iron like mud made the enemy scared, and the raw material to make it came from the captured steel plate of the artillery truck. This carbon steel needs to be forged at a high temperature of 900 degrees in order to be processed into the shape of a Tosa sword. Then it's pounded repeatedly thousands of times by two men working together to remove the impurities in the steel plate so that the body of the knife to achieve the effect of rigidity and flexibility. Then the knife is basically shaped, and a file is used to scrape out a flat blade. The strength of the scraping and the angle of the blade depend entirely on the experience of the knife maker over a long period of time. What really establishes the status of Tosha knives in the world is the quenching, the secret of which comes from the 1,000-year-old well. Because the impurities and salts in the well water are very special, the toughness and hardness of the Tosa knife can be optimized during the constant quenching process, which is also a secret that the Tosa knife maker will never divulge. After quenching, the blade is often deformed and needs to be forged again and then straightened by repeated pounding. The final step is to carve a decorative pattern for the blade. One side is engraved with a dragon and the other with a phoenix, commonly known as the dragon and phoenix sword. In order to make the Tosha knife more exquisite and noble, they coated the pattern with a layer of copper powder and then put it on the charcoal fire to bake slowly. After the copper powder is completely melted and fixed, then use a file to grind off the impurities on the surface, revealing the unique golden pattern. This kind of Tosha knife is called Go Copper knife, and will Go Copper knife maker has been very few. Originally, the Tosa knife was only used for slash-and-burn cultivation, and with its special crescent-shaped head, it could even be used as a shovel. Nowadays, they are mainly used for ornamental and collection purposes. Although Tosha knives are still handmade for hundreds of years, they have already formed a not-so-small industrial scale in the region. Each cottage is divided up into different roles, with some people specializing in carving beautiful sheaths for the knives, and others making silver knife decorations for the Tosa knives. It is these few knife craftsmen, decades as one day in the long years of perseverance, only to let this non-heritage forging knife skills to flourish. These workers who play in the mud with their bare feet are the artisans who produce the finest French perfumes. And do you know how they produce them? Farmers pick the petals of the flowers used to make the perfume and send them to the brewery, which has a history of more than 200 years. The artisans will use a large scale to weigh the petals, making it easier to distribute the proportions for brewing. Next, the workers pick up pieces of discarded tiles or bricks and pour them into copper pots, which are then filled with water from buckets. The water should neither be too much nor too little, about 80 kilograms is just right. Then the workers will pour a certain weight of flower petals into the copper pot, and then use the mud mixed with cotton around the mouth of the pot to seal a circle, and then cover the copper lid with a wooden hammer to knock tightly compaction, and a C-shaped iron hook to pull it tightly sealed. At this point, the craftsmen start to light a wood fire underneath the copper pot to heat it up, and when the hot water and petals in the pot begin to boil and steam, the craftsman will take out a hollow bamboo pole and insert one end of it into the clay pot, which contains 10% sandalwood oil, and the other end will be used to connect the holes in the lid of the copper pot to channel the steam from it into the clay pot. It is based on the principle of an ancient still, and even the connection of the sealing pipe is made in the most primitive way, using cotton cloth and mud. Next, the artisan would keep pouring water on the lid or touching it with his hand to determine the temperature inside the copper pot, because a fire that was too large would burn the aroma of the petals and too small would not get enough steam. The temperature of the clay pot must also be kept low enough to liquefy the vapor into a liquid. After a week-long distillation, they get a perfume that does not contain any alcohol or chemicals. Perfumes made in this way can stay fragrant for dozens of days even without bathing, making them a coveted ingredient for most brand-name perfumes. Here they produce only a dozen perfumes, the most precious of which is a perfume called Midiator. It smells as if it were a sweet, soothing odor emanating from dry land after it has rained. The process of making this perfume uses a lot of old clay pots and tuberose as raw materials, which are then made through repeated distillation for up to 3 months. There are only 3 other workshops that make this old-school perfume, and at $155 for 2 teaspoons, it's one of the most prized varieties. They then take the finished perfume and ship it in bottles without any blending,